In this video, I will explain you what is cyclotron. Cyclotron is simply a device to get high velocity, high charge particle. Now, how to give velocity for a charge particle? Let's say I have a charge particle here, plus Q. Now, if I am providing an electric field in this direction, there will be force exerted on it, right? Now, that force will give it a motion with an acceleration of, how will you get the value of acceleration? We know the force is equal to Q into E. Now, to get the acceleration, we also know the equation F is equal to ma. So, acceleration is equal to force QE divided by mass. This will be the acceleration. Now, this will be uniform accelerated motion because Q, E and M is constant, right? Now, I can apply the equation V is equal to U plus AT to get the velocity of moving charge after a time of t. So, U is initially 0 plus A is QE by M into t. Now, I can have any value of velocity, but the only thing I can change here is E and t. But we have a certain limit to keep E, right? To increase the value of E. Beyond that, we can't increase it. Practically, it is difficult to increase the electric field beyond a limit. The only thing what we can control is time here. We can keep the moving charges going for a longer period of time to get a higher value for velocity, because velocity is directly proportional to electric field and time here. But the problem is we have to keep in straight lane, right? When we are keeping in straight lane, that apparatus should have kilometers in length. Then only we can have a control over time. So in that kilometers, we should be maintaining the same electric field. That is difficult also. Let's say I have made an apparatus having a kilometer length, and their electric field should be same everywhere. And in that apparatus, if I am keeping one charge at one place, and for that kilometer duration, that will be accelerated, and here I can have a velocity, higher velocity. But thing is, still it is less. When we have 2 kilometer apparatus, we can have higher velocity. Now, making an apparatus and keeping electric field throughout it with the same value is difficult. So, we have made an apparatus called cyclotron. It's the same process here as well, but I will tell you how we are getting a higher velocity. So, the challenge is increasing the value of velocity when it is moving in straight lane is difficult with the size, because construction is difficult to keep an apparatus having longer length and to keep the same electric field throughout the length. Now, what we are going to do, let me explain you the apparatus first. We have 2 Ds here. So, let's say you have a metallic lunch box cut into 2 pieces, and these 2 will be the top section. So, let's say this is a lunch box, right? So, it's a 3-dimensional shape. One part of the lunch box and another part of the lunch box. Okay, now I am keeping a charge here, and at the same time I am providing an electric field here. So, let's say this is positive charge. The electric field here I am going to keep positive, here I am going to keep negative. So, this is metallic D, right? So, what I am going to do, for this D I am giving positive charge, for this D I am going to give negative charge. So, this positive charge particle will be attracted towards this. So, there will be an increment in velocity. So, from here the velocity will increase to this direction. Now, what I am going to do is, okay, one more thing you know from first chapter, electric field inside a metallic shell or metallic cavity will be 0. So, here this gap is not inside the metallic cap. Inside the D will be the cavity inside a metallic shell, and even inside, so this is D1, this is D2. So, inside D1 and D2 electric field will be 0. Why? The reason is, inside a metallic cavity the electric field have to be 0. With Gaussian theorem we have proven it. But these 2 gap, this one is gap, right? This gap doesn't come in that metallic cavity. So, here there will be electric field. So, from here till here it will be accelerated. Now, inside this, if I am going to keep a magnetic field into, so what will happen? So, this is D here. Okay. Now, the particles as, so D, this one is the top section and this is cross section. So, I have boxes in this way. So, let's say this is my lunch box. I have cut into two pieces here. Okay. So now the lunch box I am keeping here. So I have the cut here. This one is the gap. From here, charges are getting accelerated till here. Now, inside the disc, there won't be electric field. Now, I am going to provide, in that construction, I am going to provide magnetic field in this direction by keeping a north pole here and south pole here. Or you can reverse the order as well. So, magnetic field will be there from north to south. Okay, now if that is the direction of magnetic field, so let's say into, so here it is coming out, right? What is the direction of charge here? This one is the direction of charge. Okay, now with the direction of the charge, magnetic field, so this I will make it as coming out. Coming out, okay. Coming out. This is coming out. So with respect to this plane, it is coming out. Okay, now this one is the charge. Okay, charge is moving in this direction and I have magnetic field in this direction. So what will be the direction of force? This will be the direction of force. With this direction, let's say from here 0, it has came with the velocity of v. Here it has got an acceleration. Why? Because QE is in this direction and m, QE by m will be the acceleration for a time period of t. It has traveled here. Now it has got some value, right? For the velocity. Initial velocity was 0, for example. With that velocity, it has entered to the D. Inside the D, it has magnetic field in this direction into, and this is the direction of charge. Sorry, coming out it is, my mistake, coming out, direction of charge, direction of force. So what will happen? This will bend here. So this will bend and all the way till here, the same process will happen, and from here, it will come out. But if the charge plus Q come out, will it go to here? No. Why? Because here it is positive charge, here it is negative charge. Now this negative charge will not allow the positive charge to come out, because this positive will repel here and this will attract here. Now this one is oscillator. With that oscillator, we will be able to control the time in such a way that the moment it comes here, this will reverse the sign. So this is AC. AC means one time it will be positive, negative. After a certain time, this will become negative and this will become positive. Now that is the scenario here. Negative here, positive here. Now this electron with the velocity coming, and with that velocity it will be accelerated here. Why? Because now in the second case, this is V1. Now what will be V2 with this velocity? So now the charge has got this velocity, right? In the first path. Now with that velocity, it is going in circular path, and with this velocity it is coming out. So V2 is equal to V1 plus, it's the same acceleration here, QE by m into t. Now from V1 it has became V2 here. In V2 what will happen? Here also it is coming out. So what will be the direction of force? So this one is the direction of current and magnetic field is into, so that there will be a force in this direction. Clear? There will be a force in this direction and that will be rotating in this way. Now here also the velocity will be same. We know when a charge is moving in magnetic field, there won't be any change in the magnitude of the charge. Sorry, magnitude of the velocity. So with V2 here, the only thing is with that force it will be able to have a circular path. Okay, so with that circular path, that will complete a half circular motion and will come here with the same velocity V2. Now again, what will happen? This will reverse the sign, so negative and positive. Now this will be accelerated here. What will be the new value of velocity? V3 is equal to, with V2 it is coming, initial velocity plus U plus AT, acceleration by acceleration into time. Again, what will happen? With V3, that will complete a circular motion, acceleration, 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 circular motion, and finally through a hole it will come out. That is the principle. So to accelerate the charged particle, that is in between gap, there will be acceleration. And what is the function of B? Help to turn the direction of motion to help the charge to enter electric field. So what magnetic field is doing? It is just turning the direction of it is just rotating the charge in such a way that after half circular path it is again entered back to electric field, again acceleration. Now comes the picture of magnetic field, changes the direction, then acceleration, changes the direction, then acceleration. This is the process. Now one challenge here is, see, you may think that, see here it will happen very short time, in very short time. So let's say we have reversed the sign. Now this will take more time, right? More distance. This will also take more distance, which means this is happening for a very short interval of time, right? How we will be able to control the oscillator or the polarity of the oscillator? Now we will go back to the equation. We have learned this equation, right, for frequency. So R is equal to mv by qb, that we have learned. Now V by R is equal to frequency, that is qb by m. And for time period is equal to 2 pi by omega, and omega is this one, so 2 pi by qb into m. This is, so t by 2 pi by this value, simply. But see here, the time period, with the time period, is there radius mentioned? Is there velocity mentioned? Which means time period is independent on velocity and radius. That is only dependent on mass, charge and magnetic field. So here what is happening? The time taken for this circle and for this circle to complete, that is two semicircle, is the same. But the difference here is, it is of lower radius and it is of higher radius. And you can see, you can better understand this in this way. You have the velocity here, right? So velocity is related with r, that is radius. Now when the velocity is lower, then when the radius is lower, that is with the lower path, when the r is less, velocity is less. So it will take this time, I mean it will go and complete this path with a lesser velocity. So that will be, let's say, time t. But okay, the time t is this one, but this one it has completed with lower velocity. So t amount of time is taken. But with higher radius, see, when r is higher, velocity is higher. Now it is going with higher velocity. It is not the same velocity for these two. Now here it is very high velocity. It is going to complete the semicircular path. Now there also the time will be t. So that is just an explanation. But here you can clearly say that time period is independent on velocity and r, because the equation doesn't have it. Which means for this and for this it will be the same time taken. So oscillator can be easily set with that frequency. Okay, now we have to get the value of velocity of the electron coming out and energy of the electron coming out. Now let's say the D is having a total radius of capital R. Then to get the velocity you can substitute here. So velocity coming out is equal to Q into R is the radius of D, B divided by M. That is the velocity. Now how to get the value of kinetic energy? Kinetic energy coming out is equal to, here Q square B square, instead of R just keep the radius of this thing, R square divided by 2M. Very important relation. Now in the question they may give the value of diameter. So instead of radius you can keep it as diameter. So radius is D by 2. Here also you can keep it as D by 2. So we got the values of V and kinetic energy. Now we will also try to get the value of oscillator frequency. So frequency is nothing but 1 by time period. So we know the value of time period. What is the value of time period? We will derive it. T is equal to 2 pi by omega. So 2 pi by omega is nothing but QB by 2, QB by M, right? So QB by M. So this is the value of time period, 2 pi M by QB. So 1 by time period is nothing but frequency. That will be QB by 2 pi M. So 2 pi M by QB is time period and 1 by time period is the frequency, and that is the frequency of oscillator. Okay, oscillator frequency have to be set to this, then only we can have high velocity, high charge particles taken out from a cyclotron. And next thing is there any limitation for this? Yes. The only problem is we can only accelerate charged particle. If the charge of the particle is equal to 0, if it is a neutron, can we accelerate? No. Why? Because there won't be any force on a neutral particle or an uncharged particle. What will be the force? Q will be 0, so 0 into E will be the force, so it won't be accelerating. So if it is accelerating, then only we can do the whole process, like accelerating, putting it back to the acceleration again, direction change, acceleration, change in direction, acceleration. So all this process can happen only when the particles, if it is accelerating. If it is not accelerating, then there will be neither electric force nor magnetic force. So that is the limitation for this.